Yes. Yeah. Okay, Mom, don't worry. Yes, the live class of today is going to be very easy. It's not going to be difficult for the students. Don't worry about that. So, yeah, no, come on. I don't make it difficult for the students on the other live classes. No. Okay, don't worry. You'll see this one is very simple. Oh, okay, just wait a second because we are going to start. Just a second, Mom. Just wait a second. Hello, ROS developers. How are you doing? Are you ready to learn some Python for robotics? So actually today what we are going to learn is the basics of Python, and we are going to apply a little bit into robotics. We are going to use ROS in order to apply to the robotics, to the robots, but the main concern of this live class is not about ROS, so you don't need to know anything about ROS to watch this live class. And we are going to concentrate on the some basic stuff that you need to know if you want to learn ROS afterwards. Okay, and what is the question here? The question is that many people want to learn ROS, but they don't even know how to program, how to create programs, nothing related to ROS. I mean, just how to program. And what happens is that when they try to learn ROS, they have to learn at the same time how to program either in Python or C++. So what I recommend in those situations is that you forget a little bit about ROS first, and then you start learning the programming language. If you don't know neither C++ or Python, then go and learn Python. Then once you are equipped with the knowledge of Python, then you can move and start learning ROS. Okay, so that's the point that we are going to try to make in this live class today. And today we are going to learn some basic stuff about Python. And then at some point in time, we are going to apply this into ROS, very, very simple programs of ROS, okay? Okay, great. I hope that this is clear. So about what you can expect here. So now let me say hello to all the people that is here on the live class. I see a lot of people that were waiting for a long time. See here, Janice Spies, Walid, hello. I have been chatting with some of you at the beginning of before the class we started, with Lucas also. Lucas is always here. And Dominic Novak. Okay, Dominic, hello, Dominic. Dominic, he is the CEO of Husarion, is the company that has built the ROS bot. And we are going to use today the ROS bot that he and his teams, they have built. Okay, then Swapnil, let's begin. Yes, about to start. Anihilationify. Okay. Okay, and she's super ready, or he is super ready. And Haro, hello. Lucas is sending regards to my mom. Yes, just a second, ma'am. Just wait there. I'm about to talk to you. Lagan Kapoor, hello, Lagan. How you doing? And all ROS ambassadors of the construct. And Junjuan, as always. Hello, Junjuan. And then Gabriela, hello. Kuldeep, hello again, Kuldeep. And also Commander Cisco, hello. Nice to see you here again. And then Eric, Omar, Javier Rubio, Kristen, Adriana, hello, how you doing? And Julian Lopez and Causal. And I see many other people there on the chat. So welcome everyone. We are going to start. And let me remind you that we have here this chat beside the video, and use this chat whenever you want to ask me a question. If you cannot follow, okay, then you have a problem. Whatever happens, just send a question there, and maybe myself or somebody of the people also on the chat, sometimes they just answer your question. So feel free to ask there and don't get stuck, okay? Don't get stuck. The purpose of this live class is that you learn a lot. And if you get stuck, you are not going to learn a lot, okay? So that's understood. How is it going to work for the new people? I know many people already here for many live classes, but for the new people, first, I'm going to share with you a ROSjet that contains the code, it contains the notebook with the instructions, the simulations, everything ready to work here. So I'm going to share this ROSjet on a link here I will put this link on the chat that we are watching there. Okay, so you are going to see this link, click there, and then you are going to get a copy of my ROSjet, the one I have created for this live class. Then you are going to open this ROSjet, and then we are going to, all of us, all the people there on the live class, we are going to work at the same time, everyone with his own ROSjet, of course. I will use mine, yours, everyone is going to use the ROSjet. And you don't need to install anything on your computer because everything is going to be handled through the web. You only need the web browser. That easy. Okay, so let's go. First thing, I'm going to share with you my ROSjet, and I'm going to show you how, okay? Very, very easy, very simple. So the first thing, I'm going to share my screen with you so you can see what I'm doing. And here I have it, the ROS Development Studio. And this is the tool that we are going to use here in order to be able to launch everything and without having to install in the computer. So you can have a Windows, Mac, Linux machine, whatever. Here is the ROSjet of today, this one, and I'm going to share it with you. I'm going to put the link on the chat. So let me here, oh, not here, sorry. I have to change the browser. And I'm pasting right now the link on the chat. Again, this is the link for getting the ROSjet of today. Click on that link, and then once you click, you are going to get a copy of this ROSjet. Of course, you need an account at the ROS Development Studio, free account, it's okay. You don't need anything else. So everything that we do here doesn't require any special CPUs or any special GPUs or extra hours or whatever. It's just the basic free account on ROS Development Studio that is going to work. Okay, so once you have a copy like this, so you can see here they have many other ROSjets about many different things. Most of them are for the live classes that I prepare, but some other projects also, they are included here. So it depending on how long have you been working on the ROS Development Studio, you will have more or less ROSjets, of course. In this case, once you have the live class, press into More, and then open the ROSjet. Then, after a few seconds, then you should see that the following screen appears. Okay, so this is the Jupyter notebook that it's appearing here on the by default when you open the ROSjet, and it contains the instructions and all the material that we are going to follow today in order to learn about Python. Okay, so let's see. Open the ROSjet. It depends. Today we have quite a few students at the live class, and that's very cool because every week we are increasing the number of students that do attend, and maybe it's going to take a little bit more than a few seconds. In my case, I had already opened the system, so that is why it was so fast. In your case, it depends, but it can take between 1 minute and 2 minutes. It depends on the thing. So take your time on here. So I'm not going to move forward until all of you are ready. Let me check here on the chat if there is any question or any problem. Then here is Brian Kevin that says, hello, can you help me? How can a joint have two axes of rotation like the steering wheel of a car in URDF? Okay, Kevin, yes. Yeah, so it's it's a little complex to explain that now here because it's going to take some time to explain that. And then I'm sorry, but I cannot explain you that here. I can point you afterwards at the end of the class. If you remind me, I will point you towards another live class that explains about joints and creating joints in URDF. And Lagan says, Brian, may you help us explain briefly? Okay. So no, we don't have the time to, it's a different subject from the live class. I'm sorry for that, Brian, but it's going to take us a lot of time, then the people is waiting there. Then Gloria just arrived, Gloria from Palo Alto. Hello, Gloria, nice to see you again. We are about to start, so grab your ROSjet and start there. Then link didn't work, says Link didn't work. Link didn't work. People is reporting that the link is not working. Okay, let me check if I have. No, not here. Sorry. Let me click here to go to the ROS jets. Oh, something wrong. Okay, no, this is something wrong in the system. I mean, this is not normal. Let me see what is happening. Let me check. Checking. Okay, this page is not working, but I am inside here, so everything is working for me. And maybe we had. Let me type it from the original ROSDS online. Here it is opening my ROS jet already, but I want to go to the page of the project. So let me see. Okay, so there was some problem there with the connection. So can you please retry? There was some problem there, and suddenly it just solved, whatever the reason it was. Maybe it's a high load is in the system. I don't know. So ready, people is reporting, ready. Lucas and Julian, can you please retry? So because people is reporting here as ready. And even if it took a while to open. And Eric is reporting his internet is so slow. I'm sorry for that, Eric. Yes, you need a little bit of speed. Not too much, but a little bit. Okay, we are going to continue. Please, Lucas and Julian, just report. It's now okay. Okay, ready. Okay, great. Everyone, okay, yeah, those things happen. You know, we are very brave. We are doing things live. We are not showing videos. We are doing things live because we are brave at the construct. And when you do this, sometimes things doesn't work. But what is important is that we move forward and we learn a lot today. Okay, so let's go. What I mentioned, Python is very important for robotics, especially if you are going to learn ROS afterwards, because you can do everything with ROS using Python. And it's a lot simpler to learn Python than C++. It's a lot simpler to create programs. So I highly recommend that if you don't know ROS, start ROS programming with Python. So if you don't know Python, then first you have to learn Python. That's the step that we are here. So what we are going to learn here is how to create and execute a Python program for robot control. Robot controls means to send a command to move the robot or to read a sensor. So that's what we mean for robot control. Then how to define a Python function to get that data from a robot sensor, and how to create a Python class. And we are going to apply this to move a robot. So those are kind of a basic stuff that you need to understand how it works in Python. There are many other things, I mean, about how to do a loop, or how to do a conditional, but those things are very easy. You can just check the manuals for that. In those things that we are going to see here today, I think that is the meat, the real meat. Okay, so that's why we are going to talk about that. And for this class, which requirements do you need? Well, I have put here like ROS basics, but it's actually not necessary for the class of here today. Okay, so it's not necessary that you know about ROS, anything about ROS. We are going to skip about this part. But I just put it there just in case that you get curious how this Python thing is going to then afterwards work with ROS. So you can check this course there, for example. As I mentioned, we are using a ROSjet, and the ROSjet is the whole project that you have open here, and that you can get access to all the files by going to Tools and going to IDE. And here you can see the files that compose this ROSjet. And here, like, for example, the notebook that we are reading here. So we have some images here, and also the file of the notebook itself. And yeah, that code doesn't mean anything here, but it's the code that defines the notebook. So you can have the ROSjet here, and you can create your own ROSjets. In case that you're interested, check those links. For today we are going to use the ROSbot, as I mentioned, from Usarion. And first, let's launch the simulation, because we need to have a simulation running. We need a robot, actually. And because we don't have the live robot, then we are going to use a simulation. So how are we going to launch this? Well, this is a simulation that is already provided by the ROS Development Studio. So there are no extra files here for simulations today. So if you go to the simulation workspace, you will see that it's empty. Okay, it contains nothing. So how do we launch this? It's a default simulation in the construct, in the ROS Development Studio. So let's go to Simulations menu on top. First, we are going to launch the environment. That means the space in which the robot is going to move. So it doesn't matter which one. I selected the art-drawn obstacles for this live class, but actually it doesn't matter really. If you want to use another one, you can, as far as it contains some objects in the middle. Okay, then now it's starting the simulation, and it's starting with the environment that we have selected. There it is, and here we have the space of the simulation, okay? So it's an empty space, I mean, without any robot. Well, that's what I mean by empty. Okay, then now let's spawn the robot there. So for that, we need to go again to simulations, and now let's go into the list of available robots. So we go down until we see the ROS bot here on the right. Here. Something went wrong? Okay, everything is happening today here. So let me do it again. Okay, I don't understand why, because the simulation is perfectly working. Let me check, I can spawn an object here. Great, and then let's see. Okay, so I just spawned it again. I tried again, and then now it's being spawned, the robot. So the robot is going to appear here. So many problems here today. Let me see some comments on the chat. Then see Anihilationifri says, question, Python versus CPP in the robotics environment, which is most widespread and why? Comparisons. Very good question. So then it depends. So usually in research environments, Python, it's a lot more used because it allows you to create prototypes very fast. So you can check your scientific hypothesis, your tests, whatever you want to test in your scientific research. So it's a lot faster. You don't have to waste a lot of time in compilation issues, etc. That's Python. Then instead, in the industry, you need a lot faster execution times. So faster speed in execution of the robot programs. And for that, you need the CPP. So usually in industry, if you're going to create a company selling, or you're going to work for a company that is selling robots, then you are going to need to learn CPP and then apply that to ROS. But if you don't know neither of them, then start first with Python, really. Then start with Python, then learn ROS. And once you learn the basics of ROS, how it works, then you can go back, learn CPP, and relearn what it matters in ROS, for ROS with CPP, with C++. And then Julian says, I would like to add something. When using Python with ROS, you don't have to compile the package every time you modify the code, which is the case when using C++. That's great. Yes, that's correct. That is correct, Julian. Unless you create messages, okay? So that's the only change. Okay, so I have my robot spawn here, and somehow it was spawned in a very strange way. Probably the same for you. So I recommend that you pause the simulation here in this button. Here, pause. Now it's paused in my case, and then use the commands here, the icons here, to move the robot into a standard position. Okay, so I'm doing my best to put it in a standard position. Then I'm going to put it close to the ground, just close. Okay, so then I'm going to restart the simulation physics engine, and then there it goes. There we have the robot. Okay, great. So I hope that all of you have more or less the simulation working. Yeah, some people is complaining here about I'm getting CPU RAM usage too high when I spawn the robot. Don't worry, I'm also getting it, as you can see here, but the system is strong. It's going to stay there. Don't worry, just click dismissed. That's a message that we show just in order to let you know that you are getting to the top of the CPU, because this is a 2-cores machine, what you are using. And then we want to do some business. Of course, you are going to understand that we want to make some business. So what we are suggesting is please buy another instance that has more CPUs, more cores. That's this message suggesting. But if you click dismiss, it's not going to show anymore, even if we keep on 100% of CPU. Okay, so don't worry, just click dismiss. And at some point in time, in case that you want to support us, then please buy some extra packages with more CPUs. And then what else? Let's continue. I have some questions there, but I'm going to continue and go to the questions back at some moment. Okay, stay with me. So first thing, let's create a Python program. How do we create a Python program? I don't know. I want to learn. Yes. So let's see how. I'm going to put the simulation here a little bit down. And for that, what we are going to do is to create a file using the IDE. Okay, so the IDE, how did I open the IDE here? It's here on Tools, IDE. Okay, so if you open the IDE that is here for me, then you should get this. And what you should get is a list of workspaces. Then our program, it's going to be into a ROS workspace. You don't need to know about this because I have already prepared this for you. And now it's not this matter to learn about ROS, just about Python. Okay, so then trust me on this, and then at some point in time in the future, you will understand why I told you this. Because now we have to concentrate on Python. So go to the Catkin workspace, open it, then open the source directory, and you will see here there is a my Python package. Then also open it, then go to the source directory inside this Python, and then do a double click and new file. And you have to call this as indicated on the notebook. It is called my Python program.py. So when you create a Python program, you have to call it .py. Okay, so that's mandatory for identifying this as a Python program. So this is a file. We have used this IDE for creating the program, but you can use any terminal application, any other graphical tool, whatever it is, to create your file, your Python program. So I have it here, and it has been opened by default, so I can start populating this with my Python program. So the first thing that I need to do is to add the header. So let's copy the first header that we see here, copy that, and put it here. Then this header, it's indicating the operating system where to find the program that will execute our program. So we'll make let's say it's the Python interpreter. So this is where can we find the Python interpreter in order to execute our program. So when we execute our program, then the operating system knows how to start executing our program. So that's a line that is mandatory in all the files, all the programs of ROS, Python ROS. Okay, so keep that in mind. Then here you can see on the notebook that I have indicated, or for Python 3, you have to change the line by this. Okay, so what is this about Python 3? Is there any other Python there? Then yes, actually there are two main versions that are used of Python. One is Python 2.7 and the other one is Python 3. I don't remember. Then the thing is that Python 2, the one that we are using here on this live class, Python 2.7 is going to be deprecated by 2020. and only Python 3 will exist. Okay, but current ROS 1 programs, they do work with Python 2.7. That is why we are using Python 2.7 here, because we are using ROS 1. However, the next ROS 1 version that is going to be released, the next one after ROS Melodic, is going to be working only with Python 3. Also, ROS 2, it only works with Python 3. So here we are doing an introduction of Python, but we are talking about Python 2.7 here in this live class. So, but bear in mind that we have to switch at some point in time to Python 3. The thing is that not so many differences. There are differences, okay? Yeah, there are differences, but not at this level at which we are now, and for basic ROS stuff. So don't worry too much about that. And it's very easy to learn the difference. It's very easy. So now we are going to work here with Python 2.7, okay? Okay, then, so this is the first line that we need to do. Then usually in a Python program, what we do is to include third-party libraries. That means other Python programs that somebody else has done and that we want to use in our program, so we don't have to create again everything. And how do you include that? By using what we call an import. So let's copy this line here, import ROS_py. If you paste here, what this means is, hey, let's load into my program, let's load all the functions defined in the library called ROS_py. And ROS_py, it's a library that has been created by ROS, by the creators of ROS, I mean, and that allow us to use ROS functions in our Python programs. Okay, so that's why we are going to use it. So we have imported very well. Then, what do contain those libraries? The libraries that we import, they do contain three things mainly: variables that we would like to use in our program, functions that we would like to use, or classes. We are going to see all three here today. So now, next line that we are going to use is this one that is called ROS_py.init node. Copy that and put it below. What does it mean, this line? Check it out. It's very simple. You remember, we have imported ROS_py, then what it says is, from the ROS_py library that you have imported, let me use the init node function. Okay, let me use that function. And then we provide some parameters. Don't worry about this. I'm going to show you how to create a function and how to provide parameters. But what is important here to you understand is that we have imported some libraries, and then how do you call the functions, variables, or classes that have been created into this library? It's in this way. Just in this way, you indicate the name of the import, dot, and then the variable that you want to, or the function, or whatever it is that you want to use from inside there. Okay, we got it. Then this line is just a very basic line in ROS that is for indicating that this program is a ROS program. You only need to know that right now. Okay, now let's add some extra code. Is a print. Just copy this print that we have here. Print, as you know, probably from other languages or from many other information that you may have read, a print is just to show a message on the screen when you execute the program. So that's it. This is our first Python program. This is a typical Python program that is doing some things. This print is a function also, and it's a function that is provided by Python itself. By Python. So that's why we don't have to import anything, because it's already provided by Python. But it's the same mechanism. So let's execute this. So we have this file saved, and now we have to go to the terminal and execute this Python program. How do we do that? Go to Tools here. We need to open a shell. Okay, that's the same behavior that you will do into your local computer. You need to open a shell. Okay, in this case, in this environment that is on the web, go to Tools and select Shell, also called a terminal. Now, you need to move between all the directories in your computer until you reach the point of this Python file where it is located. And as you can see, this is located inside user, Catkin workspace, source, my Python package, and source. That's it. So do you know how to move there? I presume you have to use the command cd. Then you have to, because we are already on the user directory, you see this user here, this user is this user here. So let's go to Catkin workspace, UCD, then we have to type source, src, then my Python package, and then source again. By doing this, we are inside, in the terminal, we are inside this directory here. And if we do an ls, we can see our program there. There it is. Okay, now, why are we doing this? Because we need to provide execution permissions to the file. Otherwise, this looks to the system, to the Linux system, it looks like just a file with text in the inside. That's it. So we need to say, hey, this is not just text. This is a program that can be executed. How do we do that? Here we have the command, okay? Is chmod. This is very typical, so you will have to remember. csmod plus x my Python program.py. Then you do it, and then when you do an ls, you can see that now the file is in green color. I did an ls before, and it was in white. Now we know that this has execution permissions. Now, next step is to execute the program. How do we execute a Python program? Well, we have to specify the location where it is, and then the name of the program. And the location is the current directory. That's a dot in Linux. Current directory / then the name of the program, my Python program. If you execute it, then it should say, keep pushing your ROS learning. Yes, that's a print message. So that's what has been executed. It has imported ROS.py, it has created a note indicating this program is a ROS program, and then it has printed, and then end, finish, finito, terminator. But I'll be back. Then you have now the basics, very, very basics of executing a program in Python, a Python program, okay? So I hope that this is clear here. Now we are going to learn how to create a Python function. And in the meantime, let me check the questions, if there is something that I can answer. Then we have Pradeep that says, is it possible to build a product level GUI in Python with or ROS working on the backend? Yes, it is. Definitely it is. There are many libraries, graphical GUI libraries in Python that you can use for that. And I don't remember exactly one. I think that WX widget is one of those, but I'm not sure now. I don't remember exactly, but you can just look into Python GUI libraries, and that's it. And then Swapel says, connecting to remote services, it takes a lot of time to connect. Did you finally achieve that? Swapnil, sorry. Then several message retired. Then I have a second tier package, and with 2 cores, I have 38% CPU and only 11% RAM. Oh yes, that's Gloria, because you have an extra, you bought one of the extra packages that contains 8 CPUs and 1 GPU. That's why you are moving so light. I'm super happy that you have very good results with that. Then it takes time. Julian is still waiting. Waiting for what, Julian? I get an error, bad interpreter. Then remember that there is a space between env and Python. Okay, so remember that. Maybe that's your problem, Jan. Then I have read the notebook already. Okay, you are an advanced user, of course. And I forgot your name again. I am so sorry. I have I have to do some penitence because of that. So I am sorry. I will do something extra to not forget your name again. Okay, so I am sorry. Then while it says something, take key enter. Oh, as a name of a library, I presume. Gloria, no errors here, everything. Okay, so while it is providing you some Python GUI libraries. Great, let's continue then. Let's create a Python function here. So what is a function? A function is basically a set of instructions of Python that you can group together within a name. And then you can call that name at any point in time from very different points, and everything, the same code will be executed. This is very useful when you don't want to copy and paste the same code in different parts of your code. So you probably know about functions in programming, but here what you need to know is how to create one and how to call one. Then it's here you have an example of one function. Okay, how do you create a function? You have to indicate first def, this command. This is mandatory, def. Then you put a space and then you indicate the name of the function that you want to create. Then you have to put a parenthesis, open and then close. In this case, we have a parameter in the middle. We are going to see later what is parameters. And then you have to end this definition. Def stands for definition. You have to end the definition with 2 dots. Okay, then inside here, you can put whatever you want to put, that it contains the code of the function. Let's do it. Let's add one function into our already existing code. Here is an example. Okay, let's copy this and let's put it. You can copy this and you can put it at any point in time, at any point here in the code. Usually the definitions are put after the import, usually. So I am putting it there. Some coffee. Then, what does it say, this function here? It says first the def, that's normal, then the name of my function that is called print message. This is something that I have selected. Okay, so that's what I wanted to call. It's not mandatory. You can put whatever there. And then the 2 parentheses, open and close, sorry. And then the 2 dots, forgot to say that in English. I have a problem in English with the numbers and with these grammatical, the grammatical orthography code symbols. Yeah, the symbols, yeah. So yeah, so whatever, but you understand me, okay? The 2 dots there. So then after the definition here, then we put the code of the function. And you can see here something that is very, very important in Python. Please, this is very important. This is called the indentation. It's all this space here that there is nothing. It's just a space, blank spaces. So this is called indentation, okay? It's from the original definition line, we move away some spaces. The number of spaces, it's irrelevant. Doesn't matter how many, 1, 2, or 3, but you have to put some spaces after that. That means every line that you write after the definition that contains this amount of spaces is going to be considered code of the function. Is the code that belongs to the function. So in this case, in this function, only this print is considered part of the code that belongs to the function. Because after this step here, we have another code, Python code, but this line doesn't have the spaces there. Then that means, this new line, line number 8, is not a line that belongs to this function. Okay, this point is very important, and this is the source of many errors in the beginners. Remember that if you want to put another print here on the function, for example, print second message, then you have to include the spaces there. So as you can see, if you do just a carry return from the previous line, then the spaces are automatically added. This is very normal in 99% of the editors. So you don't have to care, but pay attention to that. Okay, so we have there, now we have defined a function, but how do we call it? We call it by putting the name of the function somewhere, whenever we want to call it. For example, let's call it here after the first print. Okay, so we have a print, and then I'm going to include here a call to the function, print message. The system is suggesting me already. You can autocomplete with this. Print message, then you have to put the 2 parentheses there, and that's it. Now is how I call this function. If we execute now again, you know how to execute, okay? Then we are going to keep pushing your ROS learning. First message, this is the one that belongs to this print. And then we get a call to the second print message function that is going to come here. It's going to print again the same message and then the second message here. And that's what we got. Great. So another thing that we can do in the functions is to provide parameters, not only to call, but provide parameters so the function can add it can use your parameter to compute something and provide a different result for different calls. In this case, very simple. How do you put the parameters there? You just include here the name of the parameter that you would like to get, the name, and you only have to indicate the name. You don't have to indicate the type like in other languages. That is very easy in Python, but also can lead to many problems. So, but that's how it works. So in this case, let's substitute the print message with this second print message function that we have here. You can copy this one and then substitute here the whole function by the new one. Then in this function here, you can see that there is a parameter that is called name. So now when we call the print message, we have to provide a name. And then this name is used here into the print in order to modify what it is printed. So now if we come here to the call of the function, now we cannot call it without an empty parenthesis. There, now we have to provide a name. For example, I'm going to put my name, but you can put yours. Yes, now I have included this call. I have included the parameter. Then the print message is going to receive this name inside this name variable. This is a variable, and then it's going to print the name first plus the message. So let's execute it and see how it works. Okay, something happened here. Strange thing. Okay, where it says that, it says exception on type in which line? Okay, that's a very strange message. Let me see. So the message, everything has been okay, but it looks like in the close something went wrong. And I don't understand why this, because this is correct. Everything is correct here. Yeah, so everything is correct. Okay, so I don't know why did this happen, this exception here. So that's the exact output that we should do. So first we get the keep pushing your ROS learning. That is the first message here. And then the print message that provides a parameter there. Yeah. Okay. So let me check the messages, because I see many questions there. So maybe I can solve some of them. Then I see, let me see, sorted had a spelling error. I meant the robot to spawn, haha. Okay, yeah, maybe it took some time. Xiaolong Liu. Xiaolong, I'm sorry. Look at this. I'm writing this right now here on the program itself. So look at this. I'm going to write it down here. So I'm not going to forget. Instead of Rick, I'm going to put your name. Xiaolong Liu. Okay. So I'm not going to forget. I'm sure. So Gloria, nice to meet you. Great. I get an error too when I add blank line on end of code. The error disappear. Yeah. Well, yeah. I don't understand why. I mean I don't have that end line. Now I have just added, but I didn't have it. So and you shouldn't have that. I don't understand what is that error. Okay, anyone want to learn with me? Please feel free to work. Okay, currency focus on ROS and OpenCV. Okay, very good, very good. So then you are providing your Git. Okay, very good there. Don't forget to share the link. I'm also starting with OpenCV ROS. There it is, the link. It is, okay? For computer vision, there it is. Okay. Everyone is working, it's working. Okay, let's go, let's continue. Now, you can provide as many parameters as you want. Here we have provided just one parameter, but you can provide as many as you want. So for example, you can provide here, in this case, we are providing the name and when. So let's change this function, the print message, by this new one. Then what it says is this print function now has two parameters. You can put as many as you want, just separated by commas. And in this case, it's going to require two parameters to be provided when you call it. In this case, is the name and then when, tomorrow as well. When you call it, then you also have to call this with the separated commas. In this case, it's tomorrow. And then if you execute it, okay, I think that I know what is this. It's because the auto saving, that maybe it's because it's just in the middle of saving, and that is why. Yeah, it's probably if we just do save instead of waiting for the auto saving, then it's not going to happen. Okay, nothing to worry. Yeah, so I call it with the two parameters, and then I have both parameters here. Keep pushing your ROS learning tomorrow. Okay, so you understand the thing about providing parameters. Super useful and very important. You're going to use that a lot. And then another thing that you're going to use a lot is to return values. Return values means that your sentence can return. Oh, and I forgot to. Oh, no, yeah, I forgot to return here, to add the return here. Yes, so you can create a function that computes something based on your parameters and then provides you a return with the result. So you can use this result for something. So let's do this. Let's do this now. Let's change the pre-message by this function that we have here. But in this function here, sorry, I forgot to do a return sentence. So you have to provide a return and what you want to return. In this case, is the sentence. So this sentence is a variable that is going to take the name plus the string. Okay, so let's copy everything there with the return. Copy here and substitute the function there. Okay, so now our pre-message function is requiring one name. So let's modify here the call. We don't need the tomorrow now. I'm going to delete it. And now, but still, we have to modify this. Why? Because this print function is going to return some value. and we have to grab this value return into a variable. So we are going to put it into a variable. How do we do that? Very easy. We go to the beginning of the function, and then we indicate a name of the variable. It could be whatever. My new sentence equals print message rec. Okay, so and then afterwards I can do a print of my new sentence. I know that in the notebook it says something different for the names, but it's the same. I just want to show you that doesn't matter whatever the name that you put it there, whatever this or that is going to work there. And of course you can, my sentence, I'm going to add here tomorrow. Now I'm going to do a file save here to check my hypothesis, and now launch it. And still having the error, okay? Then I have no idea what it is. So I don't know. But anyway, here you have this sentence, this print, this final print is the print that we have done here, where we are printing the return value from the function, and we have added something extra at the end, so we can also manipulate what we are returning. Great, you have an idea there. Then now what we are going to do now is to do an example with the robot that we have. The robot here is super bored there. He wants us to do something. And what are we going to do with all of this that we have learned? We are going to use, we are going to create a Python program that is going to print. It's going to use a function to print the value of the laser in the center of the laser. Okay, so the robot can detect any obstacle in the center. Okay, so that here is the program. That's the easiest program that I could think of for doing that. And let's create another program, okay, another file. Instead of my Python program, here inside the source, create a new file. So how do? You come here, do a double click, right click, sorry, and then new file. And this file has to be called obstacle underscore in front .py. Okay, so how do we do? Well, here is the whole code. Let me copy and paste. Then most of the things you already know, most of them. So here you can see the first line, that is the Python indicating to the system, hey, this is a Python program, please take that into account. Then we have the import for ROS.py. This is indicating this is going to use the ROS.py libraries. And then we have another different way of importing things from files. You see that this is a very strange way of import instead of this one. So what does it mean? What does it mean, this line? Well, this line means that instead of importing everything that is defined inside ROS.py, we are going to import just a few things, just the things that we are going to use, because sometimes the libraries are very big and we are just using just one thing of that library. One class, one function, one variable, whatever. That's a way of doing it. When you only need one or two things, you indicate here from, and then here the name of the library, where to find the library, yeah? And then in that case, import only the class laser scan. We are going to use only the laser scan. You don't need to understand what is a laser scan now. It doesn't matter, it's something related to ROS. But what you need to understand is this from import structure. We could do also from ROS.py import init node, for example. From ROS.py, here we have another function that is subscriber. We could also do that. For ROS.py, we import everything because we are working with ROS. We are going to use everything in ROS there. So that is why we used this sentence. Okay, then what do we have? We have here two functions, one function and another function. This function is one to process a scan. It's receiving a parameter that is a scan. It means all the laser rays, and then it's going to print the number of rays, and it's going to get the middle ray. The middle ray is the distance in the middle of all the rays, because I know that it's on the position 360. That is why I'm using this from the scan. The scan is an array. This parameter is going to be an array of all the ray points of the laser. And I know that on the ray number 360 is the middle ray. So that is why I'm going to get it there. So this function, what it does is process a scan value, and then it's getting just the middle ray. That's it. Then here we have another function, and whatever it does, this function is to call the process scan. So this one is calling the one that we have defined above, and it's providing the message dot ranges. So what does it mean? It means that the robot, this robot, whenever it is doing a scan with the laser, you see the laser is here, is this black thing here. Okay, let me see. Is that black thing? Oh, yeah. Here is that black thing here. So the laser is constantly scanning the environment, and then it's producing a message containing a lot of information. But in this program, we only need to use the ranges from the message. Okay, so this is how we get the ranges from the laser. And then that is what we are providing to the process scan. Yeah, okay. And then it's going to print. Then what do we have afterwards is the ROS Pi node that you already know. And then we have a special function here for ROS that is connecting to the laser. So this function is, you don't need to know now, but it's just connecting to the laser. And whenever it receives a scan of data of laser, then it calls the function get a scan. So it's calling this function here. So that's you don't need to understand this now because it's ROS based. Just understand that this is necessary in order to connect to the laser and to call this function that is going to get the scan. Okay, and then we add another function here that is called ROS Pi spin. This function is also provided by ROS Pi, and it's another function. It's another function that is going to stay there forever. It's not going to end the program. In the previous program, the program was starting here and then ending. Then it ends, finito, dead. In this case, it's going to stay here. What it means that it's going to be printing all the time here the scan value. Okay, so let's execute this one. If you have it, then first, remember, we have to change the permissions. So let's do a chmod +x of .obstacle in front. Now, if you do an ls, you have the two files with execution permissions. Then click here and then /obstacle in front. And here we have 7 to 20 and infinite. What is the first 70 20? It's this print that says the number of lasers, of rays that the laser has. And then the value in the middle, it says is infinite because it says there is nothing in the front of it. Okay, so let's put some object in front of it. For example, a cube. I'm going to click here on the cube and put it here. And it's not going to work because there is a problem, but it's very stupid thing. You are going to understand. So as you can see, my program is still here printing. So it's still printing infinite as a range. So it's not showing me the value of this obstacle in front of it. And yeah, it's not showing anything. Why? Because there is a problem in the lasers in the simulation, and then it's pointing backwards instead of forward. And if we put another cube in the back, let's put a cube here. Now you can see that the distance is being measured. So with some noise, of course, because And this is in meters. This is shown in meters. Okay, so, and you can see that if you select this and you move it, you have to move and then deselect, then you can see that the distance is increasing. Okay, so that's how it works. Very basic stuff. Now, it's super late now, it's 7 already, and we have to finish. And still we need to see how to create a Python class. So what I suggest is that you follow the instructions here in the notebook. I have tried to make it step by step, how to create a class, you have an example, and then how to use it, very, very simple, what you have to pay attention to, and how you can create an instance of the class. How you can create, very simple, and how you call the functions of that class, and how you modify the variables that belong to that class. I have also included the constructor. That's a function very important in the constructor, how to do it for a class. And then I have applied this to move the robot. So I have created a class that is called my robot that uses a constructor to connect to the wheels. And then it gets a function, it defines a function that we can call in order to set the speed of the robot. And here I show how to do this, how to call the functions of this class. Very, very simple, as you can see. I'm sorry, I wanted to put too much information here, but I think that is very important. You got all this material now in the ROS jet, so you can keep moving by yourself. Then finally, I have also included adding a main in your ROS program. Why? Because a main, usually if you have been working with other languages, then you know that the main is where the main point where the program, when you execute it, is the main point where the execution starts. Okay. Then in Python, this is not like this. The main point of execution is here at the beginning, so it goes like this. But putting in the main like this, identifying a main, that is indicating to the system that this is the main program, and what it is above are just definitions of classes or of functions. So this is a way of organizing the code that is quite good to do it. It's not mandatory, it's not very important, but when you start to create complex code, that it's good to do it. Okay, so I leave this to you, and then you try to do it. In case that you have any doubt, don't hesitate to send me a message. I'm writing down here my email, so you can send me a message with your questions, okay? Here is my email. Let me not make a mistake typing, okay? Send me the questions there. And that is all. I also wanted to make your homework, but I think that is too much now. What I would like to ask you is that you give us a like if you liked the class. And so you go to the video and then click on the thumbs up. And if you didn't like it, it's okay. You can put a don't like it, but tell us why on the comments. Tell us why you didn't like it. Oh, this guy, I don't like how he explains. I don't understand the notebook. I don't understand this, whatever. So that will help us to improve. And finally, I would like to tell you about the ROS Developers Conference. This is a conference that is going to be in 2 weeks' time. In 2 weeks' time, it's on this weekend, not the next one. It's on a weekend. It's an online conference. So you don't have to travel. You can attend from home. And what we have done is to invite 8 speakers. Here you can see 6 of the keynote speakers from very important companies in robotics. Dominic is one of those that he attended to the live class. He was over there. He is Dominic, and Tomoya from Sony, Luca from PAL Robotics, Davide, Carlos, and Ludovic from other important institutions, that they are going to come and teach you in the same way as I am teaching you here, but they are going to teach you about different subjects. You can check what they are going to talk here on this link here, on the ROS Dev Con. Just check this information there. And if you want to learn more about Python for robotics, here we have a course in our online academy. Just check it out. I have put here a link that indicates all the content that you can see. It's a basic. You are going to see how to create your classes, all the variables, how to do loops. It's quite interesting. Using different robots, a touch robot and a Summit Excel. Okay, so that is for here for today. And now let me go to the questions. Let me go back to the questions and see if there is any extra question that you would like to ask me. So let me change here, stop the screen. Hello guys, I'm back here. Ask me any question there on the chat. So I'm going to stay here for some minutes until you finish your question. Let me check. So here Commander Cisco says, how do we use the obstacle in front code from the robot commander? From the robot commander says obstacle in front code. Okay, let me check. Obstacle in front code from the robot commander. The robot commander is the other, oh yeah, okay, the code, yeah. How do you, that's a very good question, Commander Cisco. And then you have to add that information, those functions, you have to add those functions inside the class of the robot. So what I would do is to use the init function of the class, my robot, and include there the subscriber. And then there, the subscriber that subscribes to the laser data. And then the process scan and get scan, those would be functions that belong to the class also, to the class my robot. So that's how you would do it. Then you can call it from any place. I hope that this answers your question. Then Gloria, this was a great course. Thanks for this intro to ROS.Pi. My pleasure always. Gloria, thank you very much for coming all the weeks. Super cool. And then Swap Neil says, thank you for your efforts and time. It was really helpful. My pleasure, Swap Neil. Super great that you like it. Janice Pai, thanks a lot. Thank you to you also. Great content and explanation. Thanks again, Rick. Okay, Walid, my pleasure. Always my pleasure, guys. I want you to learn, really, to learn. So in case that you are not learning, you are not following, tell me in the comments. This is bad. I don't understand this or whatever. Tell me so we can do it better. Okay, so this is for your learning, this live class. Thank you, Yunjuan, Commander Cisco, gracias. Gianfranco, thank you. And Xiaolong, I remember your name. Okay, so thank you very much. And of course, check the links of OpenCV with ROS of Xiaolong that he has posted there. So happy to help that you create interconnections between you two also attending those live classes. And then that's all for today then. I don't see more questions. I hope to see you next week. We are going to do something that I don't remember now, but it's already planned. Yes, I don't remember, but Yuhon, she knows. She's in charge of promoting that. I don't remember now. Too many things on my head, but it's going to be another amazing live class, and you are going to learn a lot here. So thank you very much, guys, and see you next week, okay? Bye-bye. Hello, Mom. Are you still there? Oh, yeah, sorry. I get you waiting there. Yeah, I told you that the live class is going to be easy, no difficult. Yes. Yeah, they went okay, I think. Well, we have some problems in the platform, some small problems, but nothing important. Yeah, we understood. Yeah. Oh.